In this episode of complex number, we are going to talk about modulus of a complex number and argument of a complex number. The argument of complex number, also called as amplitude of a complex number. A complex number can be represented in xy plane called Argand's diagram. In Argand's diagram, x-axis is called real axis. Real axis represents real part of complex number. Y-axis is called imaginary axis. Imaginary axis represents imaginary part of complex number. In Argand plane, left sides of the origin are written with negative numbers and right side of the origin are written positive numbers. And above the origin, we take down the positive imaginary numbers, and below the origin, we write down negative imaginary numbers. Suppose we are given a complex number z equals to 2 plus 3i. Then how to plot this complex number in Argand's diagram? For that, we must move 2 units right and 3 units up. Repeat, 2 units right and 3 units up. Assume this complex number equivalent to a point P whose coordinates are 2, 3. Now join origin with the point P. Then the length OP is called modulus of complex number z equals to 2 plus 3i. The length OP can be obtained by using distance formula. In general, if the given complex number is in the form of z equals to a plus ib, then point P can be represented by a comma b. Then by length OP can be obtained by distance formula. Length OP equals to under root of 0 minus a whole square plus 0 minus b whole square. Thus, modulus of complex number z equals to a plus bi is equals to under root of a square plus b square. Thus, for any complex number, if you wish to find out the modulus of complex number, then simply the formula can be applied. Modulus of z equals to under root of a square plus b square. Now let us take some examples to find modulus of a complex number. Here z equals to 2 plus 3i. Find modulus of z equals to how much? In this example, first of all, we write as it is 2 plus 3i. Then comparing with standard complex number, that is the standard form, z equals to a plus ib implies 2 plus 3i equals to a plus ib implies a equals to 2 and b equals to 3. Now modulus of complex number equals to under root of a square plus b square, that is equals to under root of 2 square plus 3 square equals to under root of 4 plus 9 equals to root 13. Therefore, modulus of given complex number equals to root 13. This is answer. Now next example, if suppose z equals to minus 2 plus 3i, then modulus of z equals to how much? Then first of all, minus 2 plus 3i equals to a plus ib, implies a equals to minus 2 and b equals to 3. Then modulus of complex number equals to under root of a square plus b square, that is equals to minus 2 whole square plus 3 square equals to 4 plus 9 equals to root 13. In the next example, suppose both are negative, z equals to minus 2 minus 3i, then find modulus of complex number. Then as usual, minus 2 minus 3i equals to a plus ib, implies a equals to minus 2, b equals to minus 3. Then modulus of complex number equals to under root of a square plus b square equals to minus 2 whole square plus minus 3 whole square equals to under root of 4 plus 9 equals to root 13. Therefore, modulus of complex number equals to root 13. Now, suppose the I part is negative, that is imaginary part is negative, then find modulus of complex number. Then as usual, 2 minus 3i, comparing 2 minus 3i with a plus ib, implies a equals to 2 and b equals to minus 3. Then modulus of complex number equals to under root of a square plus b square equals to 2 square plus minus 3 whole square equals to 4 plus 9 equals to root 13. Therefore, modulus of z equals to under root 13. Modulus of z equals to under root of 13. This is the answer. So, this is the way, depending upon a and b value, we find the modulus of complex number. But one thing is that between the two number, their a square, it is a plus b square. Irrespective of the sign of a and b, the answer remains the same. Let us take combination of complex number, that is to find modulus of complex number when two are more than two complex numbers given together. Let us take one example. If z1 equals to 2 plus 3i, z2 equals to 3 plus 4i, find the modulus of z1 plus z2. Solution. Step number 1, we are having z1 equals to 2 plus 3i and z2 equals to 3 plus 4i. Then z1 plus z2 equals to 2 plus 3 and I common 3 plus 4 equals to 5 plus 7i. So z1 plus z2 equals to 5 plus 7i. Comparing with a plus ib, implies a equals to 5 and b equals to 7. Now modulus of complex number z1 plus z2 equals to under root of 5 square plus 7 square equals to 25 plus 49 equals to under root of 74. In this way, when two complex numbers together added, then also we can find out modulus. If z1 equals to 2 plus 3i, z2 equals to 3 plus 4i, find the modulus of z1 minus z2. So z1 minus z2 equals to 2 plus 3i minus 3 plus 4i equals to 2 minus 3 plus I 3 minus 4 equals to minus 1 minus I, that is Z1 minus Z2. Now comparing it with A plus IB implies A equals to minus 1 and B equals to minus 1. Now modulus of Z1 minus Z2 equals to under root of A square plus B square equals to minus 1 square plus minus 1 whole square equals to 1 plus 1 equals to root 2. Therefore, modulus of Z1 minus Z2 equals to root 2. This is answer. If Z1 equals to 2 plus 3i and Z2 equals to 1 plus 2i, there are the two questions. In the first question, modulus of Z1 upon Z2, and the second question, modulus of Z1 upon Z2. In the question number 1, modulus Z1 upon modulus of Z2. In the second question, modulus of Z1 Z2. Okay, so we'll solve step number 1. First we'll take the first problem, that is to find modulus of Z1 upon modulus of Z2 equals to question mark. So we individually find out Z1 and Z2. Modulus of Z1 nothing but under root of 4 plus 9 equals to root 13, and modulus of Z2 equals to 1 plus 4 equals to root 5. Therefore, modulus of Z1 upon modulus of Z2 equals to root 13 upon root 5 equals to root 13 upon 5. This is the result of question number 1. Now second question, we need to find out modulus of Z1 upon Z2. First of all, we find out Z1 upon Z2, that is 2 plus 3i upon 1 plus 2i. Rationalizing the denominator, we get here 2 plus 3i 1 minus 2i upon 1 plus 4 equals to 2 minus 4i plus 3i and minus 6i square upon 5 equals to 2 minus I plus 6 upon 5 equals to 8 minus I upon 5. So modulus of Z1, first of all Z1 Z2 equals to 8 upon 5 minus I upon 5. Now modulus of Z1 upon Z2 equals to under root of 8 square upon 5 square plus 1 square upon 5 square equals to here 64 plus 1 upon 25 equals to 65 upon 25 under root of. So cutting with 5 ones are 3, and so that is equals to root 13 upon 5. Therefore modulus of Z1 upon Z2 equals to under root of 13 upon 5. From question number 1 and 2, we establish one theorem, that is modulus of Z1 upon modulus of Z2 equals to modulus of Z1 upon Z2. Here I got a next question. If Z1 equals to 1 plus I, Z2 equals to 2 plus 3i. Question number 1, modulus of Z1 multiply to modulus of Z2. And the second question, modulus of Z1 into Z2. To save the time, I have already solved here I got modulus of Z1 equal to root 2 and modulus of Z2 equal to root 13. Then multiplication of modulus of Z1 and modulus of Z2 equals to root 2 into root 13, that is equals to root 26. Now the second question, the modulus of Z1 into Z2. So let us multiply Z1 and Z2. We got here Z1 into Z2 equals to minus 1 plus 5i Now modulus of Z1 into Z2 equals to under root of 1 plus 5 square, that is equals to 1 plus 25, that is equals to root 26. So we got here modulus of Z1 into Z2 equals to root 26. From the question number 1 and 2, we establish one theorem, that is modulus of Z1 into modulus of Z2 equals to modulus of Z1 into Z2. So we have understood what exactly the modulus of a complex number. Now we will move to the next topic, that is the argument of a complex number. Before doing the problem, let us go through some basic concept. Then we will be doing problems on argument as well as. Consider a ray of light is rotated in anticlockwise direction in Argand's plane. Now we will consider 4 different cases depending upon the position of ray of light. These are the 4 cases. In the case number 1, the ray of light is present in the first quadrant. In second case, the ray of light is present in the second quadrant. In case third quadrant, and in the case 4, the fourth quadrant. Now for the case number 1, consider the complex number be a plus ib. For the first quadrant, a is greater than 0 and b is also greater than 0. Therefore, the point P can be written as a comma b. From point P, draw a projection on x-axis cutting at the point A. So we got here OAP, and consider angle theta with respect to positive direction of x-axis. Now length PA equals to B and length OA equals to A. Now tan theta equals to opposite side upon adjacent side, that is B upon A, implies theta equals to tan inverse of B upon A. Theta is nothing but called argument of Z. It is also called amplitude. Now, the ray OP lies in the second quadrant for case number 2. Let Z equals to A plus IB be the given complex number for the ray rotated through an angle theta in the positive direction of x-axis. And from diagram, alpha plus theta equals to pi. Therefore, theta equals to pi minus alpha. Now we need to find out theta equals to how much. Theta nothing but called argument. That means we need to find out theta in terms of tan inverse. When the ray OP lies in the second quadrant, A is less than 0 and B is greater than 0. Therefore, coordinates of point P becomes minus A comma B. From the point P, draw a projection cutting real axis at the point A. From diagram, tan alpha equals to opposite side upon adjacent side. Taken modulus. Tan alpha, opposite side is nothing but B, adjacent side is nothing but minus A. Therefore, tan alpha equals to B upon A after taking out the modulus. Alpha equals to tan inverse of B upon A. Therefore, for the ray in the second quadrant, theta, that is the argument, theta equals to pi minus tan inverse of B upon A. Now for the case number 3, the ray OP lies in the third quadrant. Now consider given complex number B, Z equals to A plus IB. For the third quadrant, the value of A is less than 0. The value of B is also less than 0. Therefore, any point in the third quadrant is minus A comma minus B. Now from the point P, draw a projection cutting real axis at the point A. Let us call the angle O, the angle AOP equals to alpha, and this angle theta. So theta is nothing but angle made by OP in the positive direction of x-axis. From figure, theta equals to pi plus alpha because this angle is nothing but equals to pi. From diagram, tan alpha equals to minus B upon minus A modulus, that is tan alpha equals to B upon A, implies alpha equals to tan inverse of B upon A. Therefore, theta equals to pi plus tan inverse of B upon A. By using this formula, we can find out the argument of any complex number in the third quadrant. Similarly, when the ray OP lies in the fourth quadrant, then A is greater than 0, B is less than 0. Therefore, coordinates of point can be written as A comma minus B. Similarly, we can draw the projection here, and after that we can find out tan alpha, that is equals to minus B upon A. So alpha equals to tan inverse of B upon A. Now the relation that this is the angle theta, this is the angle theta we require to find out. So theta is nothing but 2 pi minus alpha. So theta equals to 2 pi minus tan inverse of B upon A. By using this relationship, we can find out argument of a complex number lying in the fourth quadrant. Next example, find argument of complex number z equals to 2 plus 3i. Step number 1, z equals to 2 plus 3i, comparing with a plus bi implies a equals to 2 and b equals to 3. After that, draw the complex number in argand plane. A is greater than 2, a is greater than 0, b is greater than 0. Therefore, given complex number lies in the first quadrant. So let us say the point 2, 3, and this value of the theta is nothing but called argument, and we need to find out theta. Theta equals to tan inverse of b upon a. Therefore, theta equals to tan inverse of 3 by 2. Therefore, theta equals to tan inverse of 1.5. By using scientific calculator, let us find out tan inverse of 1.5. That is equals to 56.30 degrees. Therefore, theta equals to 56.30 degrees. This is required value of argument of given complex number. In the next question, we got z equals to minus 2 plus 3i, and we need to find out argument. Given complex number is minus 2 plus 3i. In this case, how to find argument? Comparing with the standard complex number a plus bi, we get a equals to minus 2 and b equals to 3. Here is a less than 0 and b greater than 0. Therefore, the given complex number lies in the second quadrant of Argand's diagram. Now, from the diagram, tan alpha equals to modulus of 3 upon minus 2. Tan alpha equals to 3 upon 2 minus 3 upon 2 implies tan alpha equals to 3 by 2 implies tan inverse of 1.5 equals to 56.30 degrees. Therefore, alpha equals to 56.30 degrees. Now, what is the value of theta? Alpha plus theta equals to pi degrees, pi radians. Alpha plus theta, in terms of degrees, it is 180 degrees, and we need to find theta. So theta equals to 180 degrees minus alpha. Theta equals to 180 degrees minus 56.30 degrees. So now we subtract 56.30 from 180. 180.00 and 56.30. So 0, 7 and 3 and 2. So it is 123.70 degrees. Therefore, argument of z minus 2 plus 3i is 123.70 degrees. And suppose we keep the calculator in radian mode, then tan inverse of 1.5 equals to 0.98 radians. Therefore, alpha equals to 0.98 radians. Alpha is equal to 0.98 radians. To show the radians, we write C over there. C stands for circular degrees. So alpha equals to 0.98 radians. Now theta equals to pi minus alpha. That is theta equals to 2.16 radians. Next question, if z equals to minus 1 by 2 minus root 3 upon 2i, find argument. Here z equals to minus 1 by 2 minus root 3 by 2i, comparing with a plus ib. Therefore a equals to minus 1 by 2 and b equals to minus root 3 by 2. Now in Argand's plane, since a is less than 0, b is less than 0, therefore in Argand planes the vector OP comes in the third quadrant, and we need to find out this angle, that is a theta. So step 1, in the step 1 we can find out, first of all we draw the point. The point is minus 1 by 2 comma minus root 3 by 2. This is the point. From here we draw the projection and let us call this angle alpha. So tan alpha equals to b upon a modulus tan alpha equals to minus root 3 by 2 upon minus 1 by 2. 2 to get cancelled, implies tan alpha equals to modulus of minus, and alpha equals to pi by 3 radians. We can get the answer in terms of the degree also, but I leave it to you to calculate degree. I have calculated this problem in radians, and so the theta from the diagram, we have taken this angle as a alpha, this angle as a alpha, but this much is as a theta. So theta nothing but pi plus alpha. Therefore theta equals to pi plus alpha, that equals to pi plus pi by 3, that is nothing but 4 pi by 3. So theta equals to 4 pi by 3 is the required answer. This is the last question. Find argument if z equals to 1 by 2 minus 3 upon 2i. So z equals to 1 by 2 minus root 3 by 2i, comparing with a plus ib, implies a equals to 1 by 2, that is a is greater than 0, b equals to minus root 3 by 2, that is b less than 0. So this will come in fourth quadrant, point P, and this is required argument. We need to find out theta. So how to find out theta here? Theta is nothing but 2 pi minus alpha. Let us call this angle as a alpha. So to calculate the alpha here, we draw the projection here, and the points are 1 by 2 comma minus 3 by 2, and tan alpha equals to b upon a modulus tan alpha equals to minus root 3 by 2 upon 1 by 2. This gone. So tan alpha equals to root 3. Alpha is equal to pi by 3. But argument theta is nothing but 2 pi minus alpha. Therefore, theta equals to 2 pi minus pi by 3 equals to 6 pi minus pi upon 3 equals to 5 pi by 3. Therefore, required argument is nothing but 5 pi by 3. This is the required answer. Properties of arguments. Argument of Z1, Z2 equals to argument Z1 plus argument Z2. Argument of Z1 upon Z2 equals to argument of Z1 minus argument of Z2. So, in this video, we have learnt about modulus of a complex number and argument of a complex number. In next video, I shall be talking about polar form of complex number and exponential form of the complex number. If you like my presentation, if you are enjoying the mathematics, then you can, if you wish, you can subscribe the channel. Meet you again with another video. Till then, wish you good luck, all the best.